Alright guys, I started the recording 5 minutes late. So pause the recording and type this stuff in. And then there's a simple main that we haven't filled in underneath yet. So pause and get to it. Then unpause and continue. Okay, so we have a rectangle class here. We're going to create a rectangle. So above my pause command, rect R1 equals new rect How about just rect R1? Forget that equals new business. I slip back into Java again. Now let's set the height and the width of that rectangle. R1.h equals 100 units, whatever. R1.w is equal to 50. Now let's get the area. Float area equals R1, float area equals R1 dot get area, parentheses, end parentheses. And let's print that out. Cout, arrow, arrow. The area of R1 is, end quote, arrow, arrow, area. Arrow, arrow, EMDL. Quite often you will see people put, opening braces kind of condensed like that. I can put more code on the screen if I do that. But you see the structure and the class are defined exactly the same, right? We could have put the word struct there and listed our data. Except when you define a structure, they are by default public. What does that public mean? I'm going to make another variable, and I'm going to call it private. Private colon. And let's make it just another float, z. It's not really part of this. But down here, I'm going to try to change z. Just like I was able to change r1.h and r1.w. I ought to be able to go r1.z is equal to 50 or something like that. But it's going to yell at me. It's not going to let it compile. It's underlining that as an error. Why? Because h and w are public, right? Like the public part of your museum. You're allowed to access it. This is private. The client code cannot access that variable. Only stuff inside the class can access it. So that's the difference between the public keyword and the private keyword. And as I mentioned before, everything in a class is private by default unless you have a public keyword. Everything in a structure is public by default unless you have a private keyword.
So do we have like a password on it?
All private means is it's not accessible, right? We were able to get to H and W from here, but we couldn't get access to Z. That's all it really means. It doesn't mean it's more secure or it's encrypted or anything. It just means that the client code is the code that uses the class. You define your class and then you use it. Our client code down here created a rectangle, rect R1, and then it set some of the variables. It set H and W, and then it called get area. But it's only able to access, you're only able to make calls to or reference in the client code the stuff that is marked as public. Does that kind of make sense? Okay. Very good question.
In order to change it, you need to change it within the class, right?
Right. If I want to make it so that they could change float Z, I'd have to make a method that would change it. Let's do that, except let's not call it Z. That's kind of moronic. A rectangle doesn't have a Z. However, a rectangle might have a name. So, up here, underneath float H and W, I'm going to add a string. String name equals empty quotes, double quotes. String name is equal to double quotes. But I'm going to put a method here that allows the user to change that. Actually, if I define string there, it's public, and we don't need that method. So, cut it, paste it below the word private. All right, now we're going to make a method that can change that. So public colon, we're going to declare it as void because it doesn't need to return anything. Void set, S-E-T, name with a capital N. And what is our parameter going to be? It's going to be a name. So string, lowercase s, name. And then inside the curly braces that declare the body of our method, we're going to say this hyphen greater than name equals name. So what is that doing? That word refers to items that are inside the class. If you see the word this, you're guaranteed that it's accessing something that's defined as part of the class. You know, it's not a global variable. It's not something in the namespace defined above it, right? It's saying that this variable is actually part of the class. And sure enough, it is right there, huh? Now, honestly, I like defining all my variables, public and private, up here at the very top of the class. I don't like mixing them like this. So, if I was going to make a few changes, here's what no few changes. This makes sense. This is enough. So, why did I use this name equals name? Well, the parameter is called name. Our variable is called name. How do we differentiate the two? If we just said name equals name, it wouldn't know what we meant. We could call this something else, string s, and then we wouldn't have any confusion over whether we were referring, don't make that change, I'm going to undo it. We wouldn't have any confusion about whether we were referencing the name and the variable, in which case you could eliminate the this keyword. The only time you have to use the this keyword is when there's confusion about what you are referencing. If you are referencing a variable that's part of the class as opposed to a member of it, right? So I'm going to undo those changes and leave it as is. Okay, since this is a public method, we can set that variable. I'm going to scroll down here, and after we create R1, R1.setName, this rectangle is called R1, right? For whatever purpose. We haven't used that variable. But this is called a setter, more technically known as a mutator. What a setter does, what a mutator does, is it provides a function that will change a private variable. Well, why would you do that? Why don't you just make the variable public? We just went to a whole bunch of trouble, whereas if we called it public to begin with, we wouldn't have had to add this method. We wouldn't have had to call it like this. But the reason you do that is so that you can try to guarantee that the data is good. If we had a sphere class, maybe we're not going to allow circles with a negative radius, right? So we might have a set radius method that would set the radius of the sphere, but if they pass in a negative value, we don't allow that, right? Or, you know, if you're doing an employee class in a payroll program, you don't allow anybody to give a negative payroll for hours. That'd be a real drag if you had to pay for all the hours that you worked there. So you can make the set pay, you know, not accept negative numbers. Or the set function could check your validation, and maybe you do have something that has a password involved, and you have to log into the system in order to, you know, run it. And if they haven't logged into it, they're not going to be able to call these functions. It might check the authorization, and only, you know, admin people could change the person's salary. But, you know, if you're lower than that, if it's your own ID, yeah, you could look at it, but you couldn't change it. So that's why you provide setters, is to try to maintain the data that's in this class in a good state. If you don't care about that, you can just make everything public and be done with it. That's a valid way of doing it. But if you have concern, if you want to try to make the code a little more bulletproof, and if there's a possibility that data could be invalid, you want to put setters in there so that you don't accidentally pass in bad data, or so if you pass this project off to somebody else, they can't use the class incorrectly. Okay, so we've defined a class. I need to get rid of this r1.z business I had down here. So if you did r1.z like I did, delete it. So we have two methods. They look just like functions, right? That's a function. This is a function. but they're a function that's attached to a class. And they're functions that access the data, the variables, the members of the class. There's so many different names for these variables depending upon which book you read. Some people call them fields. Some people call them data, instance variables. Lots of different names for them. When we hit that PowerPoint, then we'll zero in on what this book wants us to call them. And then when you take Java, they might slightly use a different term. Alrighty, we've done our first class. We need to get back on the topic of arrays, but did anybody get a typo that they want help with? I hope that makes sense. I hope you got an inkling of the idea of what a class is. What you do with a class is you define the data that make up that class, right? A patient has a height and a weight and a name and a social security number and a patient number, right? So you would have class patient, and then you would have all those variables. If you have a printer object, a printer class, what do we need to know about the printer? Whether it's on or off, whether it's got paper or not, maybe how many sheets of paper, right? How many jobs are in the queue? All of that would be data that's in the printer class. If you have a drawing program, right? We have a rectangle class with a height and a width, but it doesn't contain any other information. But if we had a drawing program, you were dragging that rectangle around, you'd also want to know where it was on the screen. So you might need an X and a Y variable. And what if you rotated the rectangle? You might put a rotate, rotation in degrees, 0 to 359. Then you might want to put a fill color, right? You're dragging it around, and then you could change it to being filled with yellow rather than white. All that kind of stuff. If you did turtle programming in one of your prior classes, the turtle has all that kind of stuff. It's also got a direction that it's going, right? And it's got a state about whether it's leaving behind a pin or not, a trail or not. It's got a speed, so the turtle can speed up or slow down, right? All of that is data that would be part of the turtle class. So it's a different way of thinking. You think about everything that object has, right? Everything that makes up a turtle, everything that makes up a rectangle, everything that makes up a patient, and you list that as data. And then you create methods that interact with that. Like you're going to check the patient into the hospital. You might need a method for that. You're going to move the turtle. You might need a move command or a forward command or something like that. And those of y'all who haven't done turtle graphics have no wonder why I'm talking about them. We need to get a turtle library for C++ and play with that. All right. So onward and upward. We know what an array is. An array is a sequence of values. Here's an array that's 4 items long. I should say elements. 4 elements long, but it's been initialized to 2 values. So in memory, it's got space for 4 ints, but it's only got 2 ints in it, and the rest of them are 0. A range-based for loop. That's a different way of printing out an array. Starting in the year 2011, they stole this from C# and from Java. And when I say stole, I'm not condemning them. I'm applauding them, right? Because C# was the first to come up with the for each statement, and then Java borrowed it, and then C++ eventually got around to using it. So why do we use that? Because we like to do something like this. Int, whatever, nums. And we've got 4 nums. Equals, 100, whatever these numbers are going to be. And we want to print them out. There's 2 ways of doing that. Well, for one thing, we have to know how many nums there are. Now, there's a trick for getting the length of an array. It's the size of function. But it doesn't always work. So I wouldn't rely on it. It always works if the array is declared in the same code that you're using this function, this method. So int len is equal to size of nums. Why am I not typing this into C++? Okay, so I'm going to go down here, and underneath where it says the area of R1, right above my system pause, let's do that. Let's declare an array of nums. Int nums parentheses 4, we're going to have 4 numbers, is equal to, and then inside curly braces, type 4 numbers, whatever they are, your favorite numbers. They just better be integers. And then end curly brace, end semicolon. Alrighty, now let's calculate the length of that array. What I've been showing you previously, right, and don't do this now because we're playing with doing it a slightly different way, is I would have typed const int num's length equals 4, right? That's what I would have done to know the length. But instead I'm going to calculate it. Int len or nums len, I'm just going to use len. How about len underscore nums? That looks good to me. Equals size of nums divided by size of, now we could do int like that, or we could say the size of the first element of the array. To me, this syntax is a little bit clearer, a little shorter, so I'm going to leave it like that. Now I'm going to type the other one in, but you don't have to do it this way. len underscore nums is equal to size of nums divided by the size of parentheses nums subscript 0. They both do the same thing, right? I don't have a real argument for doing it this way over this way. You could say that, well, you have to change this data type if you change this one, right? If no, that's not true. Like if you change this to a float, you'd have to remember to come and change this to a float here. Yeah, that's true. But if this was an empty array, which you can define, you could define an empty array if you wanted to, then this would blow up there. So, yeah, 6 of one, half a dozen of the other. I'm going to delete that line entirely. I like this one. I think that's what the book shows. Okay, now let's write a for loop. But we're going to use a for index type loop. Right? For int I, short for index, equals 0. I is less than len underscore nums. I is less than the length of the array. I is less than len underscore nums, semicolon. I plus plus. That's just like your ranged loops in Python. And let's print it out. Cout for index. I'm just doing that so that we have some differentiation on the screen. And then followed by nums subscript I, arrow, arrow, endl. All right, I think we've already talked about that. Now we're going to use the other one. They call it a range-based for loop, whereas other languages call it a for each loop. So I'm going to add a comment here that this is an index-based for loop because we're incrementing an index, right? That's our index value. But the next way we're going to do it is a range-based for loop. Range-based for loop, also known as a for each loop. Now, if you ever take C#, they actually use the word each, which is cool, whereas Java and C++ and Python do not, right? For each, whatever. Okay, so for parentheses. Now, this is an array of ints. If this was an array of strings, we would put the word string here, but it's an array of ints, so we're going to do int and then value. You could shorten it to V. Colon, and then the name of our array, which is nums. See that syntax? For, parentheses, int value, colon, nums. And if you were going to read it aloud and not read off every symbol, I would say something like for value in nums, or for each value in nums, something like that. I'd be throwing you more words that you shouldn't type, right? Those are kind of colloquialisms. But specifically, we need it to look exactly like that, and then we're going to print out that value. Cout, arrow, arrow, quote, value, or for value, end quote, arrow, arrow, value, arrow, arrow, ENDL. Now I kind of made the print statement a little bit noisier by having this string here. If we deleted it, you'd see how much easier one looks than the other. Right? Maybe don't make this change that I'm making here, but look at it. Look at it. Which one of these is easier to write? That one or that one? I think the second one is easier. The only time you have to use this one is if you have to have an index value, like if you're accessing parallel arrays, or if you're changing the array as you pass through it. You have to use an index-based for loop under those two circumstances. So I'm going to undo that. All right, so let's add that as a comment. You have to use an index-based for loop if you need the index number to access parallel arrays, perhaps. Or if you are changing the array as you iterate through it. Otherwise, the range-based array, the range-based for loop, is an easier syntax, which I recommend. One of the reasons I recommend it is check it out. This for loop didn't even require a length. No constant declaration, no calculating size of divided by size of. Much cleaner, right? Honestly, I don't know how it does it. Based on what I know about C++ arrays, which is that nowhere does it store the length of the array. How in the world does that work? I know how it works in the other languages, not this one, because arrays are so primitive in C++, but it does via some miracle. So if I ask you on the exam and I don't specify which kind of loop I want you to use, I just go for the shorter one myself. But you have to know how to do this one too. And if you just committed to yourself, why heck, I'm never going to use this one and I only want to memorize that. Well, in real life you could do that. But you just need to pick the right tool for the job, really. This one is clear, in my opinion, and clarity is important. Makes your code easier to understand and to maintain, which will help you in the future as you modify it. It'll help somebody else if they have to modify your code. All right, so each time the loop iterates, it copies an element from the array to the built-in variable, right? If we go back to our code here, you see here every item in the array is getting copied into the value variable. That's why we can't change it, because we'd just be changing a copy of it. That's why I say that if you're changing the array as you pass through it, you better not use a range-based for loop. Well, you could. Let's do that. Let's do it. Let's do value. Heck, let's do it both ways. No, I don't want to get too complicated. Value is equal to -1. Right? That should wipe out the entire array. It would if we added value is equal to -1 here. The entire array would be all -1s by the time we were done. But this time it's not going to be. Well, how could we prove that? We'd have to print out the array again. It's not going to give you a syntax error. It's just not going to do it. Let's prove it to ourselves. Let's see out nums subscript 0 arrow arrow ENDL, right? And if this actually did change it, we'd see -1. But it's not going to, so we're going to really see whatever you made your first element of the array. I chose 432. Okay, so I'm going to run it, and then I'll do a walkabout, make sure everybody's where I am. All right, you see, even though I tried to set that value equal to -1, it didn't modify the original array. And honestly, that's the same in Python. And it's the same in Java and C#. So just kind of get it in your head that if you're going to use a for each loop or a for value in list loop like you used in Python all the time, or a range-based loop as they're calling it here, you can't change the value of the array as you're going through, because this is a temporary variable that contains a copy of the element from the array. I'm going to type a little bit. Don't type what I'm going to type because I'm going to delete it. But this would be exactly the same as this. For int I is equal to 0, I is less than the length of the array, I plus plus, parentheses, value, or int value is equal to num subscript I. Then print that out, C out, num subscript I, ENDL, and then value is equal to -1. These two loops do the exact same thing. These are identical loops. Now do you see why this wouldn't change the array? Because yeah, we store something in value and we change value, but it doesn't ever touch the original array. Well, neither does this one. Does that make sense? Anybody need typo correction? You're stuck. Alrighty. So, the syntax for the range-based for loop, which you can deduce from what we just typed. For, and then you give a data type. If it's an array of strings, you put string there. If it's an array of rectangles, you put rectangle there. If it's an array of ints, you put int there. And then range variable, that's your temporary variable name, which I just called value. Colon, and then the little name of the array, followed by a statement or a block of code. So, as the range-based for loop executes, its range variable, that temporary variable, contains only a copy of the array element, so you can't modify the array using that method. But in this language, unlike the others, you can actually make it so that it's a reference variable. And then you could change the values. I'd actually forgotten that. So, you know that code where we were trying to set all the values equal to -1? We can make it work. All we have to do is define this as a reference variable. We put an ampersand there, and then when we print out the value, it really is going to be -1. Alright, see, and it did change it to -1. So, as strongly as I was lecturing about how it can't change the value of it, it really can if you declare it as a reference variable. But by default, it does not. Alright. Which makes this comment wrong. You have to use an index-based for loop if you need the index number. How about we just leave it at that? If you are changing the array as you iterate through it, either use an index-based for loop or make the range variable a reference. But I don't want you to memorize this thing with an ampersand there. That's a C++ specifically, not appropriate to Java or Python or a lot of other languages. I'm going to go back and delete that. And as a matter of fact, I'm going to delete this value is equal to 1. You don't have to make all these changes, but you know, for posterity's sake, when somebody comes in. All right. All right, if you don't know the data type, you can tell the compiler, hey, I don't know the data type, or I'm not going to bother looking it up. I want you to figure it out, in which case you use the word auto. That works in more than one way. I mean, more than one context. You could do this. Auto x is equal to 3. It'll make x an int. Auto y is equal to 3.14159. It'll make y a float. Auto z is equal to, and then type in something. Okay. And then for space auto : v for value. No, wait. Don't put the colon there. auto v colon nums, cout v endl. So that's just saying, heck if I know, I don't know what nums is, just make my variable match. Honestly, I never used that. Even when I did C++ programming full time, I always knew what my data was. There's a school of thought that says when you create your variable names, you should also include the data type. Like if it's an int, prefix it with an I. If it's a float, prefix it with an F. Now people have kind of gone away from that. That was a Microsoft standard. Are we still good? Have I broken anybody's code yet? Let's try harder. All right. So the range-based for loop can be used in any situation where you need to step through the elements of the array and you don't need the subscripts. But if you do need the subscripts, you have to use a regular for loop. Processing array contents. Array elements can be treated as ordinary variables. Right? We want to change one of those numbers by adding 1 to it, we can do that. Let's write a loop that'll add 100 or 1,000 to everything in our array. You see this code, we're going to be using it so often that I'm going to wind up copying and pasting it. But anyways, okay, so we're going to write a loop that changes the values of that array. And I'm not going to use a reference because that's cheating. It makes it too easy. So, for int I is equal to 0, I is less than len underscore nums, I plus plus. You know what? Delete that and just do this. Nums subscript 0 plus equals 100. Nums subscript 1 plus equals 1,000. Nums subscript 2 plus equals 10,000. Nums subscript 3 plus equals 100,000. Now print it out again with a for loop. Just pick your favorite for loop and type it out. Like that's a real challenge when it's just sitting there on the screen, right? So that's what I'm going to do. Matter of fact, I could just copy and paste it. For auto v colon nums in parentheses, open curly brace, cout arrow arrow v arrow arrow endl. Why do we do that? Just to prove that every element of the array is a value. It's a variable in and of itself, right? So you can do things with it. You can add data in it. You could assign new data. We could have said num 0 is equal to, negative 30. Then when we printed it out, we'd see the first element as being negative 30. All right, so the last time I printed the loop, the numbers were larger, right? 532, 1,000 and something, 10,000 and something, 100,000. So we were able to change the values as we passed through, except we didn't do it with a loop. We did it like that. Now it says, be careful, don't confuse the element with the subscript. If I wanted to add 1 to everything in the array, right, and I was going to do it in a for loop, like up here, I'm just going to scroll up here. Don't necessarily do this. If I wanted to add 1 to everything in the array, and so I did num subscript I plus plus. If you put the plus plus in here, that's not going to work at all. Why? Because you're adding 1 to the index. You're not adding 1 to its value. So the plus plus would go outside it. Now delete that. Don't feel like adding 1 to everything. All right, traditionally, what else do you do with arrays? You do things like sum them up. Have we done a sum loop for arrays yet? Please tell me we have, but if we haven't, we'll do it. I'm not seeing a lot of nodding. It's where you create a variable like called total, and then you iterate through the array, adding all those. Heck, let's do it. Int total is equal to 0. That's your accumulator. Now let's write a loop. What's the shortest loop? A for value, a range-based for loop. So for auto v colon nums, total plus equals v. And then do C out quote nums total equals end quote arrow arrow total arrow arrow e and d. All right, I'm going to run it, see what my total is. Not that it matters, but see, there we go. It added up 532, 15, 10,000, 100,000, and it got that. Please remember that. This is like a very obvious test question. As a matter of fact, I'm going to list some things that I want you to remember. Things to know. The more you know. Declare an array. How to initialize an array with values. Printing the array out with an index for loop. Printing the array with a range-based for loop. And then calculating the total of the array. What if you wanted the average of it? Well, what is the average? It's equal to the total divided by the number of items. We do happen to know the number of items, right? It was called LEN, LEN underscore nums. So we could calculate that too. Int average is equal to total divided by LEN underscore nums. Could print that guy out as well. C out, arrow, arrow. Average of nums equals space end quote, arrow, arrow, average. Now, if we were awesome, we would put these in functions, right? Calculate average. And you could pass it an array, and it would add all the values up and calculate the average. Or calculate total. Because Python had some cool functions, right? You could just do sum, parentheses, and pass it a list, and it would find the sum of all those items. We don't have that in C++ with arrays. Array assignment. If you want to copy an array, one array to another, you can't do that, right? I already have an array called nums. What if I wanted a second array, a backup array, so that I can change the data for some reason? I could do something like this. Int nums2. Is this going to work? Now that's giving me grief. Okay, well, what if I specified that this is supposed to be 4 and it did nums? It's still not liking me. Okay, anyways, you can't just copy an array with an equal sign like that. If you're going to copy an array, you have to copy every element in it. So now I have an array called nums2. I'm going to copy every element from nums into nums2. Now in this case, I have to have the index value, right? Because I'm going to say item 1 index 0 is equal to array 2 0. Subscript 1 is equal to subscript 1. Subscript 2 is equal to subscript 2, and so on. So I can't use a range-based loop. I'm going to have to use the index-based loop. So for I, or int I equals 0, we're going to be able to type this in our sleep, which is good for the exam. I is less than num underscore len. Wait, I did that wrong. I is less than len underscore nums, I plus plus. And then nums 2 subscript I is equal to nums subscript I. And honestly, you'll see people write all sorts of weird syntaxes for doing this. I'm going to type, it's going to be one of those things where I type it and then delete it. But you could do this. Int I is equal to 0. While I is less than len underscore nums. Like I said, I'm going to delete this instantly. Nums 2 subscript I equals nums subscript I plus plus. That does the same thing. How does that work? Well, it copies the element from this one into this one, and then remember, if the plus plus follows the variable, it's the last thing that happens in the statement. So it's just like there was an I plus plus on the line underneath that. So you'll see people do things like that. I don't think that it makes the code much easier to read, although admittedly it is shorter. Another thing you could do is probably to put the update right there. I'm not going to mess with that. But what would happen if we took this and we put it there followed by a comma? Yeah, that would copy the array as well. Now, isn't that idiotic? You couldn't do that in any other language I know, but C, C++, they're happy to let you do weird things like that. Okay, I'm going to undo that one, and I'm going to delete this one. There's just always more than one way to write the code. I do still have the recorder going, yes. Good. So, if you're going to copy an array, you have to do it element by element. For I is equal to 0, I is less than the size of the array, I plus plus. New array subscript I is equal to old array subscript I. You can display the contents of a character array by sending its name to cout. But this only works with character arrays. In Python, you could print a list with one command, right? We could have done this in Python. I don't even think you... Feel free to do it. But all it's going to do is print out an address. It's not going to print out the content of the nums array. See there? 2, F, A, 3, 4. You had to print that out like that. But if it's a character array, and back in olden days, character arrays were how you held strings. Char, name, subscript, I don't know, 80, is equal to, quote, Joe Bob. And you could cout name at that point. Cout name NDL. Some people call this a C string or a null terminated string, null terminated array. Why is that? Because if you looked in memory, you'd see the ASCII values for J, O, E, B, O, B, and then there'd be a 0 in the last place of the array. And since we allocated this one to be 80 characters wide, probably all of them out to 80 would be zeros. Tell you what, 80 is a bit ridiculous. Let's make that 10. And let's print it out line by line as well as doing that. Let's use a index-based for loop. But we're going to print out the index number as well as the position, excuse me, as the value of the array. So, again, for int I is equal to 0, I is less than, and you know what, I'm just going to hard code the length of this guy, 10. I should have defined it as a constant, but I didn't. So I is less than 10, I++. Now let's see out that index. See out, arrow, arrow, I, arrow, arrow, quote, space, end quote, arrow, arrow, name subscript I, arrow, arrow, ENDL. So we're going to print out all 10 spaces of that character array, just to see what the data would look like in memory if we could rip open the magnetic media and take a peek. Here's what it printed out, right? JOE space BOB and then 7, 8, and 9. We don't see anything there. Oh, I am so sorry. I did not cover that. Alrighty. I'm really curious about what the ASCII value of this is. Not the character value, right? I don't care that it's an A, B, or C. I also want to see the ASCII value of it, the pure raw number. So in front of the ENDL, I'm going to add a couple more things. Cast it to an integer. INT parentheses, name subscript I, in subscript, end parentheses. And honestly, I should have put a space. You know what, I'm going to wind up spacing this out a little bit. I'm sorry. Alrighty. I'm just going to type rather than say it. Alright, like that, because I wanted 2 spaces in it. So, out of this, arrow, arrow, I, arrow, arrow, space, arrow, arrow, name subscript I, arrow, arrow, space, arrow, arrow, INT, parentheses, name, subscript I, end, parentheses, arrow, arrow, ENDL. Let's run it. Alright, you see this? See Joe Bob? Followed by some zeros here at the end. Zeros are called nulls. These are the ASCII values. If we loaded up an ASCII chart, we'd see that a capital J was a 74, that a capital B was a 66, that an O is a 111, that an E is a 101, and that a space is a 32. And I know I've cranked this thing up before, but we're going to look at an ASCII chart again. ASCII chart. Pick one. Can we find one that has all the characters, please? Thanks. Alright, so if we look, a capital B is in fact a 66. A lowercase o is in fact a 111. A space is in fact a 32. You see how I'm looking these up? Not that you can see these little red things. I know this print is small, but you get the idea. So a character array is stored like that. It's a series of ASCII values. Now, are character arrays used so much anymore? Not really, because you don't only want your program to work for English, right? You also want it to work for Russian and, you know, kanji, and this, that, and the other language, which means that you would have to have wide characters, things that are supposed to support Unicode characters. That's one of the reasons that the string class is better than using a null terminated character array to hold a name. The other reason why is because, you know, this has a length of 10. And if I put more data in it that'll fit in 10, then I'm overwriting memory. And like I said, that's a common technique for breaking software, to try to write something that'll mess up somebody's computer, writing past the end of the buffer. And so that you run into risks if you use character arrays. But you'll see a lot of old software out there done like that. You'll certainly see that kind of stuff if you're using C rather than C++. So, for other types of arrays other than character-based arrays, you must print the element by element. And we've seen this loop several times already. We've typed it like 20 times today. for I is equal to 0, I is less than array size. The only thing they're not doing is declaring I right there. And then see out that element. Or the range-based loop. For some reason they mentioned it again. Summing and averaging the array elements. We've already talked about that. You declare your total variable. No, that's just a counter. You declare your counter. We've been doing that inside our for loop. You declare your average and your sum variables. Your for loop runs through it, adding each element in turn to the sum. I called it total. And then you calculate the average as equal to the sum divided by the size. Or you can use a range-based loop to do the same thing. Finding the highest value in the array. Now our data is kind of sorted, so it doesn't really make any sense to find the highest value. We could just go to the end of the array. But what if the data wasn't sorted? Maybe your data isn't. Maybe I should change mine so it's not sorted. I'm going to do that. I'm going to go up in my code and change my data. Well, you know, see here. So that one of these is larger than the other, right? So I'm adding 1,000 everywhere, but one of them is going to be adding 100,000, right there. Now I have a reason to go through and find which is the highest value in the array. Let's do that. Here's how you do it. You declare a variable called max, and you set it equal to the first value of the array. Int max is equal to nums subscript 0. And then you iterate through the array, checking. And if the value you find is greater than max, you set max equal to that value. A range-based loop would be great for that. For auto v colon nums, curly brace, if v is greater than max, in parentheses, max equals v. You see what we're doing? It'd be like if I was just walking down the aisle asking your age, and when I found one, I'd write it on a piece of paper, and I'd go to the next person and say, what is your age? And if that one's age was higher, I would write it down on my piece of paper. That's what this is doing. And let's put a cout statement here. Cout, max value of nums array is in space, end quote, arrow, arrow, nums, nope, max, arrow, arrow, end. Now again, that sure is harder than it was in Python, where you could just use the max function. But Python was invented 20 years later after this language, so. I'm going to run it and make sure that I haven't introduced any horrible errors. Alrighty, so the average of the nums was that, the total of the nums was that, the max value was that. Let's stop here and see if we have any more array-based homework that we want to throw into the mix. Not really. Well, that's boring. Okay, we'll make one up. Homework. Create an array called rainfall. An array of floats. Of 12 floats called rainfall. Store 12 values in the array, by hook or by crook. You've seen different ways of putting values into an array. Use an initializer list. Okay. Then print the values in the array with an index-based loop. Print the values in the array with a range-based for loop, and then calculate the total of the loop the average of the loop and print those out, and then determine the maximum value stored in the array and print it out. Right, you're going to be able to do all that stuff pretty easy because we just did it. Just go back and look at your in-class stuff and you're going to be able to rock the assignment. All right. I'm going to go ahead and make the Dropbox, and then if somebody didn't get it all typed in correctly and you want to, then, you know, we have a couple of minutes after that. Does this make sense? Homework assignment makes sense? Hope so. We're going to try to finish arrays on Thursday so that you have time to take the quiz and then take time to revise it. So this will be in class QRS. Rectangle class and nums array. Come on. Alrighty, go refresh your Dropbox and give me your CPP file. And if you take your own notes on the computer, you could always upload them into that folder as well. Kind of late in the semester to say that. I'll be right over to help. Alrighty. So the folder's there, right, guys? You can get to it? Alright, good deal. Sure. Who else wants a printout? One printout, going once, going twice. See an error message again. Please don't be out of paper. You're out of paper. Alright. Well, there's a lot of stuff here. You don't need the article on child depression. I mean, maybe you do. The other kid is depressed.
Thank you so much.
Yeah, question? Yeah, that's fine. And then the maximum value is... Yeah, that's correct. That's correct. Yeah, sure.
Is underlining every single instance of C out for a while.
Right.
Instead of ambiguous. Wait. And then it's gone. Got over.
You know, that's one of those things that's nagging at me. I've seen it, and I can't explain why it happens.
Well, it's doing it for system too.
Life fixed it.
I enjoy it. Stopped. Stop the moment you came over. I didn't even show you. It was compiling.
Yeah.
Just grumpy.
Yes, sir.
I'm running behind on everything in here. I don't know if you noticed.
You'll catch up.
I'm
Yep.
slowly building back up and getting
Yeah.
in class and doing the homeworks. Am I behind on the grades wise, or is it just?
It would be my fault.
Okay, I'm just
Yeah.
making sure. And then for the one I had trouble with, one of the homeworks I had trouble with.
And so did you upload a revision?
Yeah, I uploaded a
Okay.
revision and stuff. I'm just trying to play.
Okay, I need to
I'm
make
trying to-
sure that that one got exported. I'll do that.
Okay, and then can you show me how to zip real quick?
Oh, yeah, yeah.
I haven't been
Sure.
zipping the files for you, and I know that you said you wanted them
Oh, it's all right if you do or don't, but in other classes you may need to. So like, here's my directory full of stuff. What I'm going
Right.
to do is I'm going to right-click up here, do Open Folder and File
Mhm.
Explorer. Then I'm going to close this to make sure everything's saved.
zipped. Right.
Okay, so Visual Studio Projects, apparently the one I want is Project 14, so
Okay.
I'm going to right-click on it and do Send to Compressed Folder.
Ah, okay. I think I've seen that before.
Yeah, and then it makes Project 14.
Okay, but you're okay with, because I've been taking the.
Oh, just a CPP
the
scroll.
CPP? Okay,
Right,
cool.
right.
All right. Sorry, Lou. Yeah, that's a real thing.
Yes, ma'am.
Thanks.
Summer typical C#, just C. It's an in-class one. There's a possibility I might not be in the state. Can I enroll in that one and take it online?
Enroll it and do it
or- Okay.
right.
Do they have the book available? Because I'd rather get the book before I have to leave than to try to.
Let me tell you what the book is. It's not going to be at the bookstore yet, I don't think.
Okay, I usually get it from Amazon anyway.
Right,
Where'd you
okay.
be going? Are you moving somewhere?
No, I'm just out for the summer. Let's see, Amazon.
I'll send you the text, text with the name of the book.
Okay, thank you so much.
Hope
Sure.
to see you Thursday if you can.
Yes, I
come.
will be here Thursday. Better be here Thursday.
Yeah, okay, especially depending on the weather, right?
Oh, no. I like to.
Speaking of, I'm sorry, I dropped in on her conversation.
Oh, no, no biggie.
I kind of told you, relocating to Florida this summer, right?
Right.
So I'm trying to figure out what would be the next course of action, programming software-wise. I'm gonna do probably a 2-week robotics processing automation course.
Wow, I can't imagine doing that in 2 weeks. That's going to be interesting.
Well, it's
Yeah.
it's just the certification. It's not the actual.
Oh, yeah.
It's just on your own pace kind of thing.
Okay.
But school-wise, what would you recommend next? I mean, I've had the fundamentals with you, and I've had this class with you. But Java or
Java is
Java.
a great one.
great
Right.
Okay, and then I heard her say C#. Is that?
C# is in the fall. So yeah, you could take it over the fall. That's when Java is as well.
Right.
We're also going to be doing straight C instead of C++
C, okay.
for during the summer, and that's
Okay.
actually what she's going
That's
to
what
take
she's doing.
because she's already taking
Yeah, I
C#.
was trying to figure out what just in general the next. I know Java's a big one. I've heard Java's a real big one.
Java would be where I would lead to next as your big topic.
Okay, and then how would you go afterwards? Like
I would take Java 1 and then Java 2,
Java 1 and 2? Okay.
or beginners and advanced they call them.
Right.
Yeah.
And they don't offer advanced C++ here.
Not for a while. Not for a while. Yeah.
Okay. And then.
However, C# is a good sequel to this class.
Okay. C#. Okay. Well, yeah, I'll be at either UCF or Valencia down there.
Yeah.
So, trying to work.
But even if it doesn't say it's an online course, you know how to do my stuff online.
Yeah, absolutely.
Right,
Yeah, I would
so-
love to take another course with you. I get, especially with the videos. I mean, it's been very beneficial. I was talking to her about it. That even not being here, it's not as good as being here, but
But it's better not.
Yeah,
Right,
it's better
right.
not being here. So
Yeah.
I was telling my wife, I was like, I really like this, and she was like, Yeah, you seem to like it, because I'm changing. I'm really liking the programming side.
Yeah,
of this.
good deal.
And
Good
I kind
deal.
of told you a little bit. I'm thinking about switching from electrical
Yeah.
engineering to a software developer or something. So
I've known people who did that after they got their degree.
Yeah. I just don't
Yeah.
I don't want to go and keep taking the massively math intensive courses that I might have to take.
Right.
Calculus 2 and 3 and 4 and
It's
I'm
pretty
okay with
rigorous.
Calculus
Yeah.
1, I'm good there.
Yeah.
So,
That probably would have weeded me out of around Calc 3.
Yeah, I'm struggling with
I'd rather be a
Calc 2.
programmer.
So a good programming degree, what would you recommend? Like,
Well, you could get the the 2-year degree here, but then
Well,
you're gonna,
yeah,
but then you're gonna go on to something else.
Yeah. You have
So
to.
different colleges have different kinds of degrees. Some of them call them software engineering. Some of them call it computer science.
Right. Heard
So-
of those. Okay.
Either one of those is a good way to go.
Okay. Good deal. All right, sir. Thank you.
Sure thing.
I'm gonna go home and play catch up.
Alrighty.
Some more. And stay safe with the weather coming in tomorrow.
Oh, I hadn't heard about that.
And hang on.
Nope.
Yes, PBS
Oh, great.
and possible tornadoes tomorrow and maybe Thursday.
Good boy. Alrighty.
Just in case.
Yeah. Alrighty. Thank you. She's a good boy.